Welcome to this tutorial involving pyramids and finding their surface areas and volumes. We have a right rectangular pyramid pictured on the screen. The right portion of the name means that the center of the base of the pyramid falls directly below the point for the pyramid. Keeping that in mind, we're able to find both the surface area and the volume. First, let's find the base. Well, it's just a rectangle, so it's going to be 40 by 18. Type that on your calculator, work it out mentally. Either way, base is 720 for its area. Now we've got the sides. Notice that when we have a rectangular base to the pyramid, these triangles on the left and right hand sides of the pyramid are congruent. They are two of the same thing. So on the left and the right hand sides we have two of those triangles, each of which will be some base times some height divided by 2. In order to proceed, we will notice that the base of the triangles on the left and the right hand side is 18. But the height of the triangles on those sides is really going to be the hypotenuse of the triangle that connects the point of the pyramid to the center of the base to the middle of the side. The hypotenuse of the triangle we just drew is actually the height of the triangles. It's the height of the triangles on the left and the right hand sides of the pyramid. Now be careful. Anytime I provide a height in the problem, it's talking about the perpendicular to base height. The other length is really half of the 40. In this case, the bottom of our triangle is 20. Let's call the hypotenuse x. And of course, we're going to use the Pythagorean theorem to solve for x. So we will type that in our calculator, 20 squared plus 85 squared, 7625. That's equal to x squared. We would take the square root on both sides to get the value of x. And I'm keeping all of the decimals in my calculator like we discussed in class, 87.32. I'm keeping all the decimals on the calculator, but I will only write 2 on the screen. That number that we just got is the height of the triangles on the left and right hand sides of the pyramid, so it's what goes up in the set of parentheses, 87.32. When we multiply that out, we'll get the area on the left and the right hand sides of the pyramid, and I'm getting 1571.78. But there's two more triangles involved with this pyramid. They are the triangles on the front and the back, from our current perspective, of the pyramid. They are going to be congruent as well because the base is a rectangle. So on the front and the back, we likewise have two triangles, each of which is going to have a base times a height when calculating its area that we divide by 2. The base of those triangles is 40. When we go to find their height, picture drawing in the triangle that goes from the point of the pyramid to the center, and then it kind of comes over to the center of that front and back side. It's difficult to visualize 3D in that current perspective, but we can certainly draw it out separately here. Now, the hypotenuse of that triangle will be the height of the triangles on the front and the back of our pyramid. The vertical height of the pyramid is 85. For the other dimension of that triangle, we are going to look at the picture. This length right here that I just scribbled in is actually half of the 18. So the bottom of the triangle we just drew is going to have a 9 on it. This will be a 9. I'll call it y for the hypotenuse, and again we will use the Pythagorean theorem to solve for y. We'll type that in our calculator. 9 squared plus 85 squared turns out to be 7306. That's y squared. Take the square root on both sides. And we're going to figure out the length of the hypotenuse, which is also the height of the triangles on the sides of the pyramid. 85.48. Now again, that number is the height of the triangles on the front and the back of the pyramid. So up in the parentheses, we are going to put in 85.48. We will multiply that all out. 3419.01. So we have now found the three components to the surface area of the pyramid. For the overall surface area, we would need the base, which is 720, plus we need the left and right hand sides, which was 1571.78. Again, that was the left and the right hand sides. Plus we need the front and the back, 3419.01. When we add those three items together, keeping in mind that the 3419.01 was the front and the back, we will get the overall surface area of the pyramid. Make sure you don't make a typo. Now, I'm keeping all the decimals on my calculator. It's nice if and when you can do that. And adding them up, I'm getting 5,710.79. Our unit would have to be square centimeters. Surface area involves two dimensions, so our unit would be square centimeters. One last item, the volume. Volume of a pyramid is simple. It's 1/3 the area of the base times the height. Well, in this problem, we found out that the base had an area of 720, so we'll plug that in. And if we recall, the height of our pyramid was 85. So compared to surface area, volume's a breeze. 1/3 times 720 times 85. I'm getting 20,400. Please put the correct label. That will be centimeters cubed. We have one more pyramid we will consider. What happens when the base is a regular polygon? So in this case, the base is a regular hexagon. The word right, meaning it's a right regular hexagon, means that the center of the base is directly below the point of the pyramid. We have to begin by finding the area of the base, which, remember the formula for the area of a regular polygon, 1/2 ASN. Side length is 38, number of sides is 6, but now we have to find the apothem. And remember, we draw in this triangle I just sketched in red to find the apothem. This portion right here that I scribbled is half the side length. Half of 38 is 19. The apothem is what we need to find. And if you want the measure of each interior angle in a regular hexagon, n minus 2 times 180 divided by n, where the n is 6. That will turn out to be 120. But remember, we cut it in half because of the fact that we cut the angle in half. So this is a 60-degree angle right there. We can use a little trig. Tangent of 60 degrees would be the opposite side, which is A, divided by the adjacent side, which is 19. Making sure our calculator is in degree mode, we take 19 times the tangent of 60. I'm getting about 32.91. Of course, I'm keeping all of the decimals on my calculator, but we will plug this in then, 32.91, and we will find the area of the base. So the area of the base is 1/2 times the 32.91, I'm keeping all the decimals, times 38 times 6. 3751.62. That's the area of our base. That's part of what we would need for the surface area, but we also need the area of the triangles around the sides. Now, since the base of this pyramid is a regular hexagon, all 6 of these triangles spanning the sides of the pyramid are going to be congruent. So we will find the area of the triangles. There's 6 of them, each of which is going to be some base times some height divided by 2. Well, the base is 38. Now watch this carefully. The height of those triangles that I put in blue would really be a component of this triangle that I'm drawing in green. The hypotenuse of the triangle that we drew in green, the hypotenuse of the triangle we drew in green, is the height of the triangle on the side of the pyramid. Now the height of the pyramid is 50, so that part's straightforward, but the bottom of this triangle is what gives some people grief. Notice that the bottom of that triangle is simply the apothem of the pyramid. It goes from the center, the apothem of the regular hexagon portion of the pyramid, goes from the center to the midpoint of a side. We found that the apothem is 32.91. We'll call the hypotenuse x, and we will use the Pythagorean theorem to solve for x. So it's 32.91 squared plus 50 squared equals x squared. I'm keeping all of the decimals on my calculator just so that I don't lose any precision. It turns out that 3583 is x squared. Take the square root, and we're going in decimals with this. No need to do the exact form. It would be kind of counterproductive when the apothem was a decimal. And we get 59.86. That is the height of the triangles on the sides of the pyramid, so we will plug that in, 59.86, and then we will multiply those items out. I get 6823.83. So now in this problem, when we go to find the surface area of the pyramid, it's the base plus the area of the triangles. Earlier, we found that the base area was 3751.62. And we just now found that the triangles are 6823.83. So when we combine both of those on our calculator, we will get the overall surface area. Make sure to include the correct units, at least 2 decimal places, and I'm getting 10,575.45. Our units would be square centimeters. Then for the volume, this is a pyramid. It comes to a point. So the volume is 1/3 the area of the base times the height. We've already calculated the base. It's the 3751.62. The height of our pyramid was given to us to be 50. So we will just plug that in place of the h. It's 50. And when we multiply this out, 1/3 times the 3571.62, I'm keeping all the decimals on my calculator, times 50, I'm getting 627.03. The units would be centimeters cubed. Watch the units. Volume has 3 dimensions, so the unit should be something cubed. Surface area has 2 dimensions. Area always has 2 dimensions, so its unit should be something squared. And hopefully, if you keep track of where the height of those side triangles is, it's always at a hypotenuse, you should be okay.